Today I am going to discuss some important terms: atomic number, mass number, and the neutron number. Here I have made the structure of an atom. At the center we are having the nucleus, and around the nucleus in the shell electrons are residing. This nucleus, it contains protons and neutrons. So if we see at the structure of atom, the important conclusions that we draw: nucleus is a place where mass of atom is concentrated. Second important conclusion: nucleus contains protons and neutrons. These are called the nuclear particles. Protons and neutrons are in nucleus and are called nuclear particles or nucleons. Next important thing is the nucleus is having the positive charge, and protons are going to give the positive charge to the nucleus. Protons, they are positively charged, and the neutrons, they don't have any charge on them. And electrons are having the negative charge. They are around the nucleus in the shell. So next important thing is nucleus is having positive charge. That is provided by protons present in it. Now the next is the atomic number. The number of protons present in the nucleus. The number of protons in the nucleus is atomic number. Generally, it is denoted by Z. The next is about the atomic mass number. Atomic mass number is the total number of the protons and the neutrons present in the nucleus. The total number of protons and neutrons is equal to integral value. That is the atomic mass number. It is generally represented by A. Next is about the neutron number. We know that nucleus is containing protons and neutrons. The number of protons is denoted by Z, and the total number is denoted by A. So the number A minus Z is a number that gives neutrons present in nucleus and A minus Z is our neutron number. It is denoted by N. So we have discussed about what is atomic number, mass number, and the neutron number in any atom. We are taking the topic of Bohr's theory of hydrogen-like atom. In this, the first we are going to derive an equation for the radii of permitted orbits for the atoms that are like hydrogen. There is a small nucleus that is having the positive charge on it, that is given by plus Ze, where Z is the atomic number and plus E is the charge on the proton. Around it, there is a stable orbit, and in this, an electron is revolving. Let R be the radius and V is the velocity of this moving electron. So let us consider, let E, M, and V be the charge, mass, and velocity of electron revolving around nucleus with charge on nucleus plus Z. If we see, these are the charged particles, they are having the electrostatic force of attraction because of opposite nature. And second thing is, it is revolving around a stable orbit in a circular motion, so it is possessing the centripetal force. So here, centripetal force is balanced by electrostatic force of attraction. So, according to this statement, for this equilibrium, for the stable movement of this electron around the nucleus, we have the centripetal force is equal to the electrostatic force of attraction, that is given by Newton's law, 1 by 4 pi epsilon naught. Product of the charges, we are taking the magnitude only, and the distance between them, that is r square. Mark it as equation number 1. Now, according to the Bohr's first postulate, I have discussed the Bohr's postulate in my previous topic. The link is there in the description box for the detail. So I'm using that direct from Bohr's first postulate. We have mvr, that is the angular momentum, is equal to nh upon 2 pi. According to the Bohr's first postulate, the angular momentum of this is equal to the integral multiple of h upon 2 pi. So mark it as equation number 2. Now, what we have to do, we have to square this equation and divide from equation number 1. Squaring equation 2 and dividing by equation 1. We have now m square, v square, r square, n square, h square upon 4 pi square. This is to be divided by this equation, mv square by r, four cancels with 4, 1 pi also get cancelled, 1 m cancelled, v square got cancelled. Here it will be r cube. This thing is equal to n square, h square, epsilon naught, r square divided by pi ze square. Also, we have this r get cancelled, and we have r is equal to n square, h square, epsilon naught, pi ze E square. We are having here the radius is equal to n square h square epsilon naught pi z e square. Now, if we look at this equation, this is the radius around which an electron is moving in a circle is being given. So, this is the equation of radii of stable orbit. One more important thing that is concluded from here, where n is the integral multiple, it is 1, 2, 3 and so on, depending upon the number of the orbit that we are taking. The rest other things, they are standard constant, h, Planck's constant, epsilon naught, permittivity, pi, z atomic number, e is the charge on the electron. So from here we conclude that this radius is directly proportional to n square. So there is direct proportionality of this number square on which this radius is depending on. Now in the next step, we are going to find out the velocity of the electron that is moving around the stationary orbit, and we are again considering that mass is the m, charge is e, and velocity of the moving electron is v. Now according to the Bohr's first postulate, we have the angular momentum mvr is the integral multiple of h upon 2 pi. So from here we have v is equal to nh upon 2 pi mr. Also, we found out the relation for the radius. This is equal to n square h square epsilon naught. It is divided by pi z e square m. Now, mark it as equation number 1 and this as equation number 2. Put the value of r from equation number 2 to equation number 1. Put value of r from equation 2 to equation number 1. What we get? V is equal to nh upon 2 pi m. Now n square h square epsilon naught pi z e square m. So here pi cancels with pi, 1n goes with square, m goes with m. So we have velocity is equal to 1h also get cancelled out. The value of the velocity we get is z e square upon 2nh epsilon naught. So Bohr calculated this velocity for the first orbit of hydrogen atom taking z equal to 1, and here the first orbit n will be equal to 1. So the value v1 we are taking for the first orbit is equal to e square by 2h epsilon naught. Putting these values, the velocity comes out 2.19 into 10 power 6 meter per second. So this is the velocity of the first orbit of the hydrogen atom. If we divide this by the velocity of light, e square upon 2ch epsilon naught. Here we have divided this velocity by the velocity of light, and the value comes out 1 by 137. If we see, this ratio is a pure number, and this number is called fine structure constant and denoted by alpha. V1 by C, as we see, is this ratio is a pure number, and this is called fine structure constant. This is denoted by alpha. So alpha is V1 by C. The value is 1 upon 137.